right, hey y'all, Mr. Kyle, Myers Mathematics, and let's just jump into it. We are going to talk about the convergence tests, plural, because there's typically 10 of them, and I'm going to kind of do a side-by-side, like put them all together in a way that hopefully makes sense. So this is not looking at a particular test or a particular problem, but more of like a big picture kind of view of everything. I'm actually going to be getting into more specific convergence tests and stuff like that soon, because I'm restarting the series on series that I'm doing in a few days. Every month that has 30 days, that's what I'm doing. So check that out. That should be somewhere in the description at the end of the video, or maybe in the description of this video. So if you want to see specific examples, that's going to be some of the others. This is going to be a big picture view, like a forest view. And I'm also going to go through these in the order that you would typically be taught them, but every teacher teaches a little differently. So your teacher might not cover them in this order. And that's okay. It's more or less going to be like this. Most professors are going to teach them relatively in the same order. So the first test typically that you learn is actually the only test that only tests for divergence, which is ironically, or maybe unironically, called the divergence test. So number one, the divergence test, which is sometimes called the nth term test. This is my least favorite name for it, the nth term test. I don't think it makes any obvious sense. Like, I kind of get why they call it that, but it's not as obvious as the names for some of the other ones. Divergence test is a lot more on the nose, and I prefer it that way. That way it's easy to remember what it does. It tests for divergence, so it's called the divergence test. When I was first taught this, it was just called the limit test. So sometimes I'll just default to calling it that. But I think my preferred title for it is actually the divergence test because, like I said, it's on the nose. So the divergence test, or the nth term test, or the limit test. That one has the most amount of names. The rest of them don't have that many. I think there's one other one that has 2 names. Most of the rest of them are all called the same thing, no matter which book or professor you're listening to. Okay. So then we get to probably my favorite test. After that, no, actually, number 3. Number 2, typically the second test. That's the wrong shade of green. Hold on. We can't have this. There we go. That's better. Okay. Probably my least favorite test, actually, is the integral test. Not that I don't like taking integrals. I'm fine with taking integrals. I tutor mostly Calc 2, so, I mean, I do a lot of integrals. And my email is down below if you want to contact me about tutoring, or you can check out my website, myersmathematics.com, and I have my tutoring stuff on there, so you can check that out if you want. But that's typically what I tutor, so I'm not against taking integrals, but as far as all the different tests go, I don't know, maybe it's kind of nice to just have a reprieve after doing so many integrals for the majority of everything before this unit on series, that I'm just like, oh, it's kind of nice to just not have to take an integral to get the answer. So maybe that's it. I'm not really sure. But it's probably my least favorite test, but it will test for both convergence and divergence. Then we get to, or at least a version of number 3 is my favorite. And let's make that go away. The P-series test. And that one kind of, I guess I would put an asterisk on it, because I don't actually like the textbook version of P-series. I think it's a little too restrictive. I use a version of P-series that I call the K-series test. K for Kyle, because that's my name. So, you know, it is what it is. It's great. And I don't know if I've already made a video on the K-series test. I made a video on why I thought the P-series test was the best, and I probably talked about the K-series test in that video. So, yeah, I'm going to have, at the end of this video, if you want to just skip to it, I'll have the link to the playlist on series, and that video is in that playlist on series, since I'm kind of in that mode right now. So go check that out if you want to see why P series and or K series is the best test out of them all. But even if you're using the textbook version, it's a really clean test. It's really simple. It's really straightforward. It's easy to use. It will tell you convergence or divergence. So even if you're using the textbook version, it's still pretty good. Then, if you're doing the textbook version of P series, you'll have either the direct. So I'm going to put this in a bracket because sometimes it's called the direct comparison test, and sometimes it's just called the comparison test. Comparison test. Can you see that? You can see that. Awesome. So sometimes it's called the direct comparison test. Sometimes it's just called the comparison test. And you know what? Convergence, divergence. This actually doesn't test for either one. So I'm going to change the color of this. I didn't leave a note for this. I'm going to change this. Instead of red being giving the answer, let's have that be like a different shade of blue maybe. Because red, I think, would be the right color for tests for neither. Tests for both would be green, right? Because blue and yellow make green. Tests for neither, or neither if you prefer to say it that way. Tests for neither. Yeah, I think we're going to go with that because the direct, not direct, direct. There we go. The direct comparison test on its own won't tell you the convergence or divergence of anything. It's used in conjunction with something else. So if you're familiar with the Marvel universe, or at least Sony's Marvel universe, Venom. Venom is a symbiote. He, pairs up with, either like Eddie Brock or Spider-Man or whoever, and gives them extra superpowers or regular superpowers, and makes them stronger. But he can't really survive on his own. It's kind of how direct comparison test works. It doesn't really test for anything on its own, but if you pair it with something, typically the P-series test, then it can produce results. And the same thing for the limit comparison test, which is my favorite out of the two. Limit comparison test. So the direct comparison test and the limit comparison test. And those are the only two that are sort of symbiote tests. The rest of them will test for one or the other or both. Most tests test for both. Okay, let's go back to that shade of green there. Because typically the next one after that, is the only test that I know of that only tests for convergence. So it actually pairs really well with the divergence test. And this would be the alternating series test. Alternating series test. There we go. So there's one test that tests only for divergence, which is a great test. It's kind of restrictive, but it's really easy to use. So I like that test a lot. The alternating series test is also fairly simple. I probably I'll have other videos where I go into detail about how to actually use it, but basically it boils down to three things. You want to kind of take out the negative 1 to the power of n, or something similar to that. You take that out, and then what's left over is called b. B has to be greater than 0, always positive. It has to be decreasing, so its derivative has to be always negative. So it has to be always positive. Its derivative has to always be negative, and its limit has to be 0. Positive, negative, 0. Series has to be positive, or the B sequence has to be positive for all n values, decreasing for all n values, and the limit as it goes to infinity has to be 0. Which is why I pair it with the divergence test, because if the limit of B is not 0, then it's very, very likely that the limit of A is not 0. So if the limit of A is not 0, then it just diverges because of the divergence test. And then you wouldn't use the alternating series test. You would use the divergence test. So there you go. So 1 and 6 pair pretty well. So that's alternating series test. Next up, let's go over the two tests that do give you the answer. So we're going to go with, they do give you the answer, and they'll tell you whether it converges or diverges. So maybe like that green color I was going to use earlier. It's a different shade of green. So these are different in that, so let's see, what do I want to call this? I don't know if I even have enough space for that right there. Let's go ahead and go to the next line. So the geometric sum test, or the geometric series, I'm just going to call it the geometric test. There's several different versions of this name, but I don't know if I'm going to write them all out because they're not that different, right? Like divergence test versus calling it the limit test versus calling it the nth term test. Those are very different sounding things, so it was worth writing all that. But the geometric test, or the geometric sum test, or the geometric series test, the infinite geometric sum test, they're all pretty much saying the same thing. They've got the word geometric in there somewhere, and they've got the word test in there somewhere. So the two essential words are geometric and test. And that is one of the only tests that actually gives you the answer. The other one is the telescoping test. Telescoping test. So the geometric test and the telescoping test. Very nice, very nice. So that leaves us with only two more left. And both of these also test for convergence and divergence. And I really like these tests as well. They work for really complicated things. And that's why they're typically taught last, because they work well for crazy stuff like factorials or n to the n power or the nth root of n or whatever. Ratio test and root test. Okay, so last thing I want to do here is I want to actually set up two different lines. I want to have set up a convergence line and a divergence line. And I'm going to do this because I think it'll be a good way, and I do this with my students, and they seem to really like this, so maybe you will too. If I set up a line for convergence and divergence, all right, so this is going to be the convergence line. Convergence and the divergence line. And this is going to be very hand wavy. This is not technical. It's just a way to try to remember the semi details of each of the tests. Okay, so it's very, very hand wavy. It's just something to help remember some of the nitty gritty, because there's a lot of tests. 10 tests is a lot of tests, and you got to know how to use them. And so hopefully this will help you to know how to use these tests. So since the divergence test is the only one that's yellow, I'm going to use yellow to describe that one. And so with the divergence test, basically if the limit is not 0, then it diverges. So if I get anything other than 0, then it diverges. Anything other than 0, even if it's like some weird like negative infinity or infinity, or that's it. It's just not 0. If it's not 0, then it diverges. That's it. Like sine, right? Like a sine wave doesn't have a limit that converges to anything, which means the limit's not 0, which means it diverges. It is what it is. So that's it for that one. And then subsequently, the alternating series test only tests for convergence. Basically, if the limit is 0, then it converges. Now, the sum itself, or the sequence, has to be always positive. It has to be always decreasing, but the limit has to equal 0. If the limit is equal to 0, then it converges. See how those two pair together now? If it's 0, then it converges. If it's not 0, then it diverges. Now, that's obviously way oversimplifying it. So just stick to the actual tests when you're testing them. But that's why they pair well. One of them, you want it to be 0. The other one, you don't want it to be 0. Okay, let's get to some of the other ones. And I'm going to have to start using different colors here to differentiate what's going on here. So I'm going to get a couple different colors here. Different shades of green, mainly, I think. We're going to go with... What other kind of shades can I do? You know what? Let's just go with the shades that are listed here. That way I don't take too much time. We'll do an orange for one of them. And then... oh, I guess that was gold, actually. JKLOL. That's actually orange. And then red doesn't actually test, right? So comparison and limit comparison don't actually test for convergence or divergence, so they don't really have... I'm not really going to put them on the convergence or divergence. So we'll go ahead and skip over to a dark purple for another color. Okay, so I think we'll have the integral test be like a gold. The integral test will test for convergence or divergence. Basically, if you get an answer, any answer, so not the arrows themselves, but any finite answer, then it converges. But if you get like infinity or negative infinity, then it would diverge. So the integral test is pretty straightforward. If you can take the integral, and of course I'm simplifying, right? So like if you want the very nitty-gritty stuff and your professor wants the nitty-gritty explanations, then you know, this video is not gonna get you there, but it'll get you part of the way there, right? Again, forest view here. But integral test is really straightforward. So, I mean, I feel like I'm a little unfair with the integral test because it's actually a pretty good test. If you can take the integral, it either works or it doesn't. If it works, then it converges. If it doesn't, it diverges. And that's pretty much it. P-series, the p-value, so the series of 1 over n to the p power is what it would have to be written as. When p is greater than 1, when p is greater than 1, it converges, and when it's less than or equal to 1, it diverges. So there's your p-series test. All right, we're going to skip direct comparison test and limit comparison test because they don't test for anything on their own. We already did alternating series, so now we're on to geometric. For geometric, it converges if the r value, ar to the k, I like to remember it as arc, like Noah's Ark. If you need an arc, I know a guy. If it converges, it has to be between -1 and 1, the r value. So that's our convergence area, not including 1 or -1, but something in between. So, of course, if it isn't in between, like if it's -1 or less, or if it's 1 or more, then it would diverge. Telescoping test is kind of hard. It's kind of like integral test. So we're actually just going to go ahead and give this the same color scheme as the integral test. Because basically it either works or it doesn't. If you can use telescoping test, then it will either tell you that there's an answer or it will tell you that there's not an answer. If you can't use the telescoping test, then you just have to try some other test, just like integral test. If there's no way to take the integral, or if it's insanely hard to take the integral, so it's just not worth your time, it would be better to use some other test, then use some other test. But the telescoping test and integral test are actually pretty close in that if you can use the test, it works if it works and it doesn't if it doesn't. Now, the nice thing about telescoping, though, is that the telescoping test like geometric, will tell you the answer, as in like what the sum actually is. This is something that I forgot to mention with integral. If you get an answer for the integral in the integral test, that answer is probably not the sum. It could be, but it would be kind of just a happenstance. If you get an answer for the integral test, it just means that it converges. It doesn't necessarily mean that that answer is what it converges to. So be really careful with that. Telescoping test, though, will tell you if there's an answer, whatever that answer is the answer, the sum. So there you go. And ratio and root test actually have the same rules. So when I switch colors here, let's go with a light blue. I really like blue. Blue's my favorite color. So, and I don't think I used that shade, did I? Is that shade? Oh, that is that shade. Or is it? It looks lighter. We'll go with a darker shade just to make sure it's different. Yeah, there we go. Okay, so with both the ratio test and the root test, both of them, they do different things. Ratio is dividing a sub n plus 1 over a sub n, and then root test is going to be the nth root of a sub n. But the result of that, you take the limit of the absolute value of the result of that, and if that result is between 0 and 1, because you're taking the absolute value. So because you're taking the absolute value, it can't be less than 0. If that result is between 0 and 1, not including 1, but it could include 0. If that result is between 0 and 1, then it converges. If that result is greater than 1, it diverges. So notice what value we're missing out of that. If it's less than 1, it converges. It's an absolute value, so it can't be less than 0. It can be between 0 and 1. If it's less than 1, it converges. If it's more than 1, it diverges. If it's exactly 1, you didn't do anything wrong necessarily, but it just didn't work out. You got to try a different test. And it's unfortunate, and you can't really know for sure whether it's going to be 1 or not. You just kind of have to try it and find out. And that's what makes this unit kind of hard, is like you don't necessarily always know exactly what the right test is to use in every single scenario. I mean, for the most part, you can kind of know which test to use. And I'll probably get more into that as I keep continuing into the series on series. But you won't always 100% of the time know at the onset, like, oh, I know this test will work, and it'll tell me, convergence or divergence. Over time, you can get better at that, and you can increase that percentage to close to 100%. I would say most of the time, I'm able to figure out whether it converges or diverges right off the bat. But that's because I created my own series. Like, I created my own test called the K-series test, which works on, like, 99% of everything. So, it's just one of those things where it's like the more you practice it, the better you get at it, right? Like anything else. So anyways, I'm probably rambling at this point, and we'll go ahead and close the video here. Hopefully this was helpful. This is the forest view. If you want to see other stuff in the series, that should be popping up somewhere around there. And then you can also check out my website for more information and resources and things like that, like the 5 math mistakes everyone makes and how to avoid them. Go check that out. It's a free PDF guide you can get on my website, myersmathematics.com. Catch you in the next video. Blessings, y'all.